Okay, so let's talk about theoretical probability now. The theoretical probability is found whenever you want to make use of a formula to find the probability of an event. And that formula is basically going to be the number of favorable outcomes divided by the number of possible outcomes. Now, for this formula to work, we need to make two assumptions. First, we need to be able to count the number of favorable and possible outcomes. So we need to assume we can count those. We also need all the outcomes to be equally likely. For instance, if I want to find the probability of heads when I flip a coin, I need to assume that heads and tails are equally likely. And then so the theoretical probability of heads would be 1 favorable outcome, heads, divided by 2 possible outcomes, so 1/2. Now, this diagram you see here on the right shows 4 ways to count 4 ways that 2 coins could fall. You can see that it could be that both coins are heads, so heads, heads. Maybe the first coin is heads and the second coin is tails. Maybe the first coin is tails and the second coin is heads. Or maybe they're both tails. Now in this case, we're going to assume that heads, tails, and tails, heads, those are considered to be different possibilities, different outcomes. And by that I mean outcomes are the most basic possible results of a random process. Now, events is an event is just some combination of outcomes that all have the same property of interest. So, for example, here my events are just the number of heads when flipping 2 coins. So here's the event of 2 heads. You get just 1 outcome. The event of 1 head has 2 different outcomes: heads, tails, tails, heads. The event of 0 heads has 1 outcome, that's both tails. So notice that flipping 2 coins shows 4 outcomes and 3 events. The event of 1 head occurs twice. Alright, let's take an example. Suppose you roll a die. In this case, the possible outcomes are 1, 2, 3, 4, 5, or 6. Now, if I want to find the probability of 1, well, I'm looking at that there is 1 favorable outcome divided by 6 possible outcomes, so the probability is 1 out of 6. If I want to find the probability of a 3 or 6, well, in this case, there are 2 outcomes that are either a 3 or a 6. So the probability would be 2 out of 6. If I want to get a probability of anything except 2, well, 5 of those are not 2s out of 6, so the probability is 5 out of 6. And then the probability of 8 or more, well, none of them are 8 or more, so the probability is 0 out of 6. When I roll 2 dice, you can see here and find the sum, you can see there are 6 by 6, there are 36 outcomes that are possible. Now suppose I want to find the sum of 7, so there's one right here, there's a second, a third, a fourth, fifth, and sixth. For instance, this one here occurs when you have a 5 up here and a 2 over here, so 5 and 2 add up to 7. But there are 6 outcomes that add up to 7. There are 36 outcomes overall, so the probability is 6 out of 36. What about the probability of rolling 2 dice and getting a sum of 10? Well, there's 1, 2, 3 outcomes that involve 10s out of 36, so 3 out of 36. You might notice from my answers, you don't really have to simplify your fractions. If you want to leave it as 3 out of 36, that's perfectly acceptable for this class. It's the one class where you don't need to simplify. Okay. A ball is randomly chosen below. What is the probability of the ball is at most 6? So I count there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 balls. And at most 6 means 6 or less. So there's 1, 2, 3, 4, 5, 6 that are at most 6. So the probability is 6 out of 11. Here are 20 dots in the graph. What is the probability a randomly chosen dot is at least 7? 7 is where this red vertical line is. Well, there are 20 dots overall. And at 7 here, there are 2 that are at least 7. 7 or more. So the probability is 2 out of 20. And this one has 60 dots. And the question is, what is the probability that a randomly chosen dot is at most 6 or at least 14? So again, overall my denominator is going to be 60. Now for the numerator, notice there are 1, 2, 3, 4, 5 dots that are at most 6. There are 7 dots that are at least 14. So at most 6 or at least 14. Overall, there's going to be 5 plus 7 or 12 dots that are at least 6, at most 6 or at least 14. So the probability is going to be 12 out of 60.